practice of circular economy. So first things first, we need to know that Malaysia is actively transitioning toward a circular economy. Before this, we have blueprints such as Wawasan 2020, but we move on past that. Now we have 12 MP, or known as RM-12, which is the 12th Malaysia Plan to align with the Global Sustainable Development Goals (SDGs). So it comprises 3 dimensions. Firstly is economic empowerment, environmental sustainability, and lastly social engineering. So today we are going to focus on the economic empowerment and also environmental sustainability of Malaysia Plan. There are about 20 keys. Okay, we are going to focus about that. So moving on, this is the circular economy blueprint for solid waste in Malaysia. So it is introduced by KPKT, which is the Housing and Local Government Ministry. It has the objective of envisioning a clean, sustainable and prosperous nation by fostering cleanliness. So it has 20 key initiatives. We are going to focus on only 3 for today, which are sustainable production inputs, extending production lifespan, resources recovery. But for this topic, because we are going to talk about the innovative solution, we are going to focus on sustainable production input. So it is to design durable products, align with the 9R framework, and integrate renewable, recyclable or bio-based material into production. So what do we have here? What I'm going to propose here is eco-brick. Some countries even use them to build buildings for library or even school. A bio-building component that can also function as an insulating panel. As you can see, the first one is from sugarcane biogas, and then we have from eggshell, and then we have plastic waste, and lastly, any kind of waste. We are moving on to the research background on eco bricks. So firstly, we are going to talk about conventional bricks and its characteristic. For clay bricks, it provides high strength, but it also costly. But then we have also cement brick. It has lower price, but it has a significant impact on the environment, and that is why eco brick comes in handy. It is a bio-building component and also reduces carbon footprint, which is good for the climate change. It improves the thermal insulation properties of brick. However, for the proper identification is using sugar bagasse has higher compressive strength than common brick, but however, it is not enough for engineering brick. So here you can see the table that lists 3 samples, and the sample 3E is the one that has the most sugarcane bagasse and also shell component in it, and it has the lowest compression strength, which is about 5.33. Fall under the requirement of engineering brick.
I will be presenting an innovative solution that support Malaysia's shift to a circular economy, which is the eco brick. So these items from food and agricultural waste into durable eco-friendly construction materials. So what is an eco brick actually? Eco brick is a sustainable building material made by combining food waste like shells, coffee grounds, or sugarcane, I don't know how to pronounce it, starch pulp with the agricultural residues. So the result is strong, lightweight and low carbon brick suitable for construction. So actually what is matters? Malaysia generates a huge amount of food and agricultural waste each year. Most of it ends up in landfills or get burned, which will releasing harmful emissions. So eco-bricks turns that waste into a valuable resource, reducing landfills and cutting carbon emissions. So actually how it works? So eco-bricks are produced in a factory setting using prefabrication. This ensures quality and reduces waste at the construction sites. Recyclable or biodegradable binders are used so that brick can be reused or composted at the end of their life. As for digital tool, what is digital tool? So blockchain tracker. A blockchain-based digital system tracks the entire life of each brick from waste collection to final use. So this ensures transparency, supports recycling, and help contractors to manage the materials over time. We propose a 3-part strategy. First, technology, which is to partner with universities industry to test and refine the formula. Link it to BIM, which is Building Information Modeling, to smart planning. As for finance, seek government grants, eco-financing, and form a public-private partnership, which is a PPP, to share risk and funding. So the third one is operation, which you can see at the slides, and some of it is like build production hubs, new farms and food centers, train workers in a modular construction using these bricks. And then we go to the circular economy principles, which eco-bricks align with the circular economy in 3 ways. First, they reduce the need for raw materials. Second, keep materials in the use through reuse and recycling. And then third one is to regenerate value from waste instead of creating pollution. As for the benefits, so eco-brick offer multiple benefits actually. So as for the environmental, it is less waste, fewer emissions, reusable materials. And then for economic, it is lower long-term costs, especially in waste deposit and material usage. And the last one is for social, new green jobs and community involvement in sustainable building.
Assalamualaikum. My name is Ahmad Azrul Ikhwan, and today I will talk about the cost-benefit analysis. Here's a cost-benefit analysis for eco-bricks made from agriculture waste, specifically sugarcane bagasse and shells, which is framed within circular economy principles and applied to a real-world construction challenge in Malaysia. Referring to our cost-benefit analysis for the cost component per ton of eco-bricks, these are sub-components which are sugarcane bagasse collection, shells, binder, labor, energy, equipment depreciation, and transport plus miscellaneous, which is the total cost of that is 1,750 ringgit. For the benefit components per ton of eco-bricks, the components are market price of eco-bricks, avoided waste disposal cost, carbon dioxide reduction value, carbon savings, and government support incentives, which the total benefit approximately 3,100 ringgit. These are the net profit, which are the benefit components deducted by cost component, and it will get 1,350 ringgit per ton, which 77% return per ton while creating socio-environmental value. The impact for economics is 1,350 ringgit per ton, which can boost rural income and local entrepreneurship. For the environmental, 30 until 50% lower carbon dioxide avoids burning landfilling, greater than 500k tons of waste annually. For the social, jobs in local manufacturing, skills development, housing for P40 groups.
Innovative approach is our first step to making our construction practices more environmentally friendly. Let's start with the reduction of carbon footprint. By using these eco-bricks instead of traditional cement-based bricks, we can reduce carbon dioxide emissions by up to 80%. This significantly plays a vital role in pollution reduction and climate change mitigation. Next, we have resource efficiency improvement. These eco-bricks are made from waste materials rather than new raw resources. That means we use less energy during manufacturing and still end up with a product that is not only strong but also lightweight. It's a win-win for both sustainability and structural efficiency. Finally, looking at waste diversion rates, this innovation helps transform agricultural waste, especially sugarcane waste, into valuable building material. As a result, we are able to keep millions of tons of waste out of landfill every year, helping reduce environmental degradation and pressure on waste management system. Okay, let's talk about the innovation behind this eco-brick product. This project focuses on transforming agricultural waste, specifically sugarcane, bagasse, and shells, into strong, usable brick. This not only helps reduce the amount of waste sent to landfill, but also makes better use of leftover resources that will otherwise be discarded. It's a creative and practical solution to a growing environmental problem. And number two, compared to the traditional brick making, this process significantly lowers pollution and carbon emissions. By embracing these methods, we are promoting greener and more sustainable construction practices, helping to tackle the urgent issues of climate change and environmental degradation. And finally, by using local materials, we are not just protecting the environment, we are also boosting the local economy. It reduces transportation costs, support local suppliers, and most importantly, encourage Malaysia construction industry to shift toward more innovative and eco-friendly building solutions. So overall, this innovation is more than just a break, it's a catalyst for environmental, economic, and industrial change. Okay, for the others relevant informations, we have first recycling and upcycling. The eco-brick approach aligns more upcycling than traditional recycling. While recycling breaks down materials to reuse them, upcycling takes it a step further, adding value and creating a new functionality out of waste. This supports the broader circular economy by optimizing the product's life cycle and reducing the need for virgin resources. Next, future research and innovation opportunities. The potential doesn't stop with sugarcane waste. We can expand this concept to include other agricultural byproducts found in Malaysia, such as like rice husk and palm oil waste. This opens up a wide wider range of sustainable consumption options and encourage ongoing innovation in the building industry. And finally, the potential for multi-sector collaboration. This project is a great example of how different sectors can work together, specifically agriculture and construction. By using waste from one sector as a resource for another, we not only reduce waste but also foster collaboration that can lead to more sustainable and efficient practices across industries.